In the previous video, we had a look at a few rules for naming the hydrocarbons with functional groups. We name the compound with a prefix that is decided by the number of carbon atoms in the parent chain. On the other hand, the suffix is defined by the functional group present in it. So according to our table, we have various suffixes that are used for naming the compounds. We have ol for alcohol, al for aldehyde, on for ketone, and oic acid for carboxylic acid. The case of halides is however different. We can either write it in the haloalkane style or in the alkyl halide style. Haloalkanes are written with the prefix chloro, bromo, fluoro, or iodo respectively before the parent hydrocarbon. In contrast to this, alkyl halides are written with the alkyl group as the first part and the respective halide as the second part. This is what we've learned so far. Now let us try taking a simple example to understand the nomenclature better. Maybe we can begin with a compound having just one carbon atom. What is the prefix used when we have one carbon atom? Yes, it's meth. And is it a saturated or an unsaturated hydrocarbon? Of course, it has to be a saturated one. For double or triple bonds to exist, it should have more than one carbon atom, right? Yes, so we consider a methane molecule. Now, when we have an alcohol as a functional group attached to the methyl group, the name changes to what? We know that the methyl group is derived from the methane as the parent hydrocarbon. So from the word methane, E will be replaced by ol, and thus the compound becomes methanol. Similarly, when we have carboxylic acid as the functional group, the second part becomes oic acid. So methane will become methanoic acid. And what if methane has an aldehyde group as a functional group? In that case, we will replace E with al. Thus methane will become methanal. Now what if a ketonic group is the main functional group? Take a moment to answer this question. Based on the table, it has to be methanone, right? That's not the correct answer. But why? We know that the ketonic group comes with a suffix -one. Yes, that's right. But the name of the compound is incorrect. To understand this, first tell me, what is the structure of a typical ketonic group? It is something like this, correct? One carbon atom is attached to an oxygen atom with a double bond. And what do the R and R indicate? They are the alkyl groups that can be attached to the ketone molecule. Both can be same or different alkyl groups. Now the lowest possible alkyl group is the methyl group. So imagine we have methyl groups attached on either side. Won't the structure be like this? Yes, absolutely. Now how many carbon atoms are present in this compound? 3, that's right. So is the parent hydrocarbon methane now? Of course not. Needless to say, it will be propane, and that is why the compound becomes propanone. The E is replaced by -one. So does it mean that the ketonic group is not attached to a methane or even an ethane chain? Yes, propanone is the smallest ketone to exist. To be precise, it's 2-propanone. But we will focus on the numbering system later. For now, what is important for us is propanone. Lastly, we have the halides to be included in the list. In this case, the name can be written in 2 ways. And what are the 2 ways? Yes, either in the alkyl halide fashion or in the haloalkane style. So when fluorine is attached to the methyl group, the compound becomes fluoromethane, or it can even be named as methyl fluoride. On attaching chlorine to the methyl group, it becomes chloromethane. And what will be the second way of naming it? Yes, it will be methyl chloride. Now with the same logic, could you name these 2 compounds for me? Yes, this will be bromomethane or methyl bromide. And this will be iodomethane or methyl iodide. This is how hydrocarbons with functional groups are named. Is it easy to name higher order hydrocarbons with functional groups? We see that in the next video.